Hello Internet. Welcome to part 7 of MERN full stack tutorial series. In last video, we reviewed MongoDB, set up MongoDB in Atlas, connected to DB via Mongoose. We looked at the environment variables and .env package. We reviewed context parameter and passed Mongo schema to resolver via context parameter in Apollo GraphQL server. We also created data in DB via mutation. In this video, we will implement authentication. So on the VS Code, I am on video 7 branch. The graph, the server is running. Express is server is running and connected to MongoDB. So before we start coding for authentication, let's organize our code in resolver. So right now we have the index.js file in resolver, and it has all the resolvers what we have created so far in the one single file. So first thing to get rid of is this mock data. We connected to MongoDB and we will be interacting with DB. So the mock data has served its purpose. We no longer need it. So let's delete that. Second, similar to mutations or similar to type def, we had author type def, book type def, and all of them are merged into this index. So we need to do something similar here in resolver. This resolver will start getting very busy as we start implementing for all the queries and mutations. So for that, in resolver folder, let's create a file user resolver.js, and let's copy all from index, and let's say it is user resolver. Now, so this both books and book are for book resolver. So let's remove them. So in mutation, we have this register. So register is for user. So let's keep this here. Similarly, let's create, and before I forget, let's export user resolvers from this file. Let's save it. Create one more file for book resolvers.js. Again, let's copy everything from index. Let's call this book resolver and export this book resolver. So query books and books are related to book resolvers. This mutation is related to user. So let's remove this. On index, we don't need these two here. So let's first require book resolver. Book resolver, call it book resolver. Let's get user resolver also, call it user resolver. Then let's export both book resolvers and user resolver. So on index, the main index at the book backend level, we don't need to make any changes here. The resolvers, what we called is from GraphQL and resolvers. So resolvers, we didn't define any file name. So it will look for index.js. And from there, it will get access to both user resolver and book resolver. Let us open the user type def and Mongo schema side by side. So I'm splitting the screen. We have user resolver here. Let's open user type def and finally models here in Mongo. So we can't simply save the user based on the user ID, email, and password. We need to do few checks before the user is created. So the first thing is, let's look at the user type def. So here in the registration input, we are taking care of mandatory values like email, password, and confirm password. So if we try to fire a query on mutation registration register without any one of these fields or variables, then it will give an error. For example, let me open the GraphQL playground. So we had saved this registration register query in the last video. So for example, if I take out this confirm password field and try to run a query, we will get an error here at the mutation level. Also, when we create the front end on the UI side also, we can make those fields, user ID, email, password, and confirm password field mandatory so that the form is not submitted itself. So we have those mandatory checks in place already. Next check is we need to have the password and confirm password same. Otherwise, we need to return an error. So let's do that here. So we have the input. So let's extract email, password, and I think there is a typo here. So let's fix it. Confirm password. Uh, okay, so let's extract confirm password also from input. So first is if password is not equal to confirm password, we need to throw an error. The message will be password and confirm password don't match. Let's save. Let's go to the GraphQL and also change the type here. So let's say I made an error in password and confirm password. Okay, we are getting the error password and confirm password don't match. The error message we gave here. So the second check, so the user will not be created here because the check is failed. The second check, what we can do is we can enforce a password length. So let's just do a simple password dot length is not equal to, let's say, 6 characters. Then we'll throw a new error. Let's save it. Let's try that now. Password. Let's keep confirm password and password both same so that this error message is not thrown, but it is now only 4 characters. So let's execute and we get password must be at least 6 characters long. Now next we also need to implement another check. If a user with this email ID is already registered, we cannot add or create one more user with the same email ID. So the email ID has to be unique. One way to implement the unique email ID in our book club project is to find the user with this email ID in this resolver. So we can write user collection dot find with this email ID. If that is true, then throw an error. The other easy method is to create a unique index at the database level. On MongoDB, we can create a unique index on email ID. So if we try inserting records with duplicate email IDs, then database will throw an error. So let's try implementing the unique index on at the database level. So I have logged into the Atlas account. So we used, there were on the clusters, there is this connect option. So we use this connect to application for connecting it via VS Code. So here we can use this connect via shell option. So we can copy this string. Let's head back to VS Code and let's expand the terminal. We can add one more terminal here and we can paste the connection string. So now it's asking for the password. Let's paste it or type in. Now we are connected to MongoDB from the from this terminal. So first let's see what are all the databases. So this admin and local are created by default. We can, and the database which we are interested in is book club database. So let's use that. Let's see what are all the collections we have in this database. So we have one collection, that is user collections. db dot user collections dot find. Let's see what are all the records. So before this video, I deleted the IDs which we had created earlier. So we are going to create the index and we are going to create the unique index. So it shouldn't have the data. The prior trials we had added couple of users with the same email ID, so that will error out. So we need to have this user collection clean before we implement the unique index. So before we create the unique index, let's see what other indexes we have that we can find using get indexes method. So by default, this underscore ID is indexed. So we need to create an index on email. So the way to do that is db.usercollections dot create index. It takes in an object. The object is first the name of the field which you need to index, and whether you want it to be ascending or descending. One is ascending, minus one is descending. It doesn't matter for our application, but let's just keep it ascending. Another object which it takes is whether it is unique or not. So just creating index will not be a unique index. So we need to enforce this unique constraint on that index. Okay, so now let's see the indexes created. Now we have the two indexes. One, the ID which is created by default, and this is the second index we created on email ID. The key is email and the unique is true. So from now on, if we try to insert any records with duplicate email IDs, then MongoDB will throw a index error. Unique index is created on the email ID. Let's now test it out. Let's first try creating a valid account. Okay, I'm still getting this error. Password must be at least 6 character long. The password is 8 character. Let's go and see what is the issue on the server. Mutation. Oh, so I said not equal to. The condition should be if it is less than 6. Anything less than 6 should be fine. Okay, so instead of not equal to, I change if it is less than 6, it should throw this error. Again, the nodemon is running. We have the server up. Let's try this again. Okay, so now we got the true message. Let's try creating the same ID, same user one more time. Okay, now we are getting the Mongo error duplicate key. This is because we implemented the unique index. Let us create one more user. Let's say p1 at test, and we'll keep password same. Okay, so this is also created successfully. Now let's switch to VS Code, the second terminal where we connected to MongoDB. Now user collections dot find all, and let's just pretty print it. Okay, so we see two email IDs, two users created, one with p at test, second one is p1 at test. What next need to be done is this password is now saved in database in clear text. So this is definitely not best practice. It's a security issue. So in database, we have to save the password in hashed format. That's what we are going to do next. To hash the password, there is a package called bcrypt. Let's use that. So let's first stop this terminal. Let's open a new terminal. Let's go to backend. and npm install bcrypt. Bcrypt is installed. We can see that in package.json. So let's use this in user resolver. So let's require bcrypt and call it bcrypt. Then in the user resolver, before we save the new password, so let's call a function called bcrypt.hash. It takes the parameter or the password and the number of what is called as salt rounds. The higher the value, difficult it is to crack it. Let's call this password hash, and this is a async function. So let's use await. Anyway, we are in within the async function, so this will work fine. Now, instead of saving the password as is, let's save the password hash. Let's save it and let's run our server npm run start server. Server is running. It's connected to MongoDB. Now let's go to our playground and let's write another mutation, this time with p2.test. This is true. Let's go to the Mongo terminal and let's pretty print again. Now let's see, this is the password. This is the hashed password. Though we gave the same password here, it is hashed. So now even people who have access to the database will not be able to see the password in clear text. Let's run one more test. This time let's say p3.test. Let's run it. It's well, true. Let's go to the terminal of, let's go to Mongo shell. Let's pretty print it. Now notice here, so even though both P2 and P3 had same password of the text password, the hashed key is different. The hashed password is different. So that is the strength of bcrypt. It will be difficult to hash or crack the password looking at this key alone. Next, we will implement the login functionality. To implement login resolver, let's go to the mutation object. Just below register, type in login. It's an async function, the arrow function. Then first parameter is parent, which we are not going to use. Similar to register, we will have input in the arguments, and in context we need to extract user collection. Then we are dealing with the database collection, database operation. So we need to have try catch. If there is an error, throw new error, and let's make it a sync arrow function. So if you see the login mutation, the input type login input has two fields, email and password. So we have defined them as non-nullable. So we will always get the values for these two fields before it hits this resolver. So let's extract email and password from input. So once the email and password are extracted, we need to find the element or a user if it exists with user collection. So the way to find that is user collection dot, there is an function called find one. We are finding it by email field. So this is a database operation, so it has to be await. Let's call it user in DB. So let's just console log it for now. User in DB and return. Say hi. Let's start our server. Okay, the server is up. Let's go to our playground. So we had this mutation of register. Let's just comment it out. Before commenting it out, let's just copy, comment, and paste. So here we want login input, and instead of register we need to do login. And in the headers, in the query variables, we just need to pass email and password. So now let's keep this side by side. Okay, so now we passed in the email which exists in the database. So the ID we are getting the ID, we are getting the email, and we are getting the password. And let's just try with the ID which does not exist. So in that case, we get a null response. So we can look for the null condition of this user DB, and if the user DB is null, if not user in DB, then we can throw an error, throw new error, we'll say account not found. Else, next what we need to do is, if the code doesn't throw an error at this point, that means we have the email in DB. Next thing is we need to compare the password. So now this password which is stored in database is hashed password, and when user try to log in, that will be the plain text password. So the way to compare whether that password is correct or not, bcrypts provide a function called compare. It takes in plain text password, that is this password, and the hash password. The hash password is user in DB dot password. This is also await function, async function. So let's just call it is correct password, and then let's console log is correct password. Let's save it. Okay, so now we are giving the wrong email ID, so we should expect the error account not found. Then let's give the correct email but give the wrong password. So if we see the console log, this is correct password is false. If we pass in the correct password, this bcrypt function, the compare function, gives in true. So we can use this return value is correct password. If it is not, that means the password is not correct. So let's throw new error. So let's say incorrect credentials. Then if the account is found and if the password is correct, that means we are logged in. So let's return logged in for now. Okay, so now we have the correct password. We're getting the message logged in. If we give wrong password, we should get incorrect credentials. Currently, after logging in successfully, we are just sending a static text of logged in. This is not very useful though. What needs to happen is once the login is successful, the server needs to give a piece of information to client and client needs to store it. Why this is needed? Because there are uh, certain operations which only a logged in user is allowed to do. For example, in our book club project, only logged in user can view uh, and borrow books from other users. Only logged in user can add a new book. So when the front end or client is sending or firing that query to add a book, for example, it needs to pass in that information which server has sent after successful login. And in turn, what server will do is before performing add book operation, it will decipher the information from client to check that the correct user, the A user has logged in. And second, if that operation is specific to the logged in user, so the database update is done properly. The package name is json webtoken. Okay, so in package.json, we're seeing JSON web token is installed. Now, instead of saying logged in, we need to pass in the token. So before that, let's require JSON web token and call it JWT. JSON web token has a function called sign, which helps in creating the web token based on the payload. So we called JSON web token as JWT. The function is sign. It takes in a payload. The payload we can use, one is from the user in DB. So we can give the ID part of it and let's say the email. So we want to include the logged in or user in DB ID and email as part of payload to this JSON web token. So when we receive the JSON web token from client, we will be able to extract the email, the ID and email of the user. Second is it needs a hash key. So the hash key, we have defined another environment variable in .env called jwt secret, and right now it is just a top secret. We need to make it as complicated as possible in production, which will be changed later in this for this project also. So here let's get that environment variable process.env dot json web jwt secret. And third parameter, which is optional, is to define the expiry for this JSON web token. So it takes an expire SYN key and the value is I'm giving it as 1 day. That means this JSON web token will be valid for 1 day. We can give it in hours, minutes, seconds also, and in days. So once this time passes, that JSON web token which was created will no longer be valid. It mimics as the session is timed out. The user has to log in to get the new JSON web token. So this is an async. So let's call it with await. Let's call the output as the token. So now instead of just saying logged in, let's pass the token. Now let's go to the playground. MongoDB is connected. The Express server is up. So now we had passed in the wrong password. Let's try it again. So we're still getting the incorrect credentials. So let's go to the password and let's try logging in. So now we are getting this login token. So from this token, we will be able to extract the ID and email, which are the payloads we sent when we were creating the JSON web token. So that part of extracting the ID and email we will implement in next videos. So in this video, we implemented the authentication. We used the bcrypt and JSON web token packages. And in next videos, we'll continue to implement other resolvers. That's it for this video. See you in next.